Hello friends, welcome to our channel. I hope you are all in a very good health and studying well with your full focus. Thank you for joining me. Today we are going to discuss about real and apparent depth. It is from the chapter Refraction of Light. So let us first understand what is real and apparent depth. An object placed in a denser medium when observed from a rarer medium appears to be at a depth lesser than its original depth. So, to understand this statement, we need to draw a diagram. So, let us see the diagram first. So, this is our diagram where O is the object which is placed in a denser medium. We assumed it is water. So inside water we have placed an object and we are observing this object from a rarer medium. Let us assume O is the object which is placed in a denser medium. We can assume the medium as water. Now AB is the boundary between two media. Our first medium is water and our second medium is air, which is optically rarer than water. Now we can assume that two light rays are coming out of A. One, the first ray striking the boundary perpendicularly. That is why it does not suffer any deviation. It goes straight into the rarer medium. And the second ray, which is OQ, when strikes the boundary obliquely due to refraction, it changes its path. It bends away from the normal. So the refracted ray is QC, as you can see. Now, if we place our eye in the rarer medium, our eye will not be able to see the bent path. So it will assume that the light ray is coming from this point. Okay, actually the object is placed here, but our eye will not see the actual path of light. It will, when we um, extend or produce the refracted ray backwards, it will meet the, the perpendicular ray at this point. So here we will observe the image of this object. Obviously, this is a virtual image. So we can see the object is placed at a depth of PO. This is called the real depth. But our eye will see the object at this position. So this depth is called apparent depth, PI. This is called apparent depth. Now, if we now the difference between real depth and apparent depth is called the shift. So this length is our shift, the distance between I and O. This is our shift. Now we can find the relation between real depth, apparent depth, and refractive index of the medium. This is n dashed is the perpendicular at the point of incidence at point Q. So now let us find the relation. So when we see an object inside water, we actually miscalculate the depth. We are actually observing the image of the actual object. Okay. We assume the depth to be lesser than its actual depth. Now let us understand it. SO is parallel to NN dashed. Why? Because these are the perpendiculars on the same straight line AB. So these two lines should be parallel. Now, if we say that OQ is the transversal, then this angle and this angle are alternate angles. So we can say N dashed QO, N dashed QO, and QOP. QOP. These two angles should be equal because they are alternate angles and they are equal to I. Again, SO is parallel to NN dashed and CI is our transversal. CI. So these two angles are corresponding angles. So we can say CQN, CQN and QIP. These two angles are equal because they are corresponding angles. Now from the triangle QOP, QOP, the bigger triangle, sine of angle I is equal to perpendicular by hypotenuse. That means PQ by OQ. Perpendicular by hypotenuse. So we have written it. Now for the smaller triangle QIP, sine of angle R is equal to perpendicular by hypotenuse. So PQ by QI. It is already written. Now if we say that the refractive index of second medium with respect to first medium, that means the refractive index of air with respect to water in this case. Okay. So refractive index of air with respect to a given medium is equal to sin I by sin R. We already know it from Snell's law. So sin I by sin R, this is the ratio. Now we can cancel PQ, so it becomes QI by QO. qy by qo. Now we can write refractive index of medium with respect to air. Okay, the opposite of this. Okay, the opposite of this, refractive index of medium with respect to air will be equal to reciprocal of this thing. Okay, we know this. This comes from the principle of reversibility of path of light. So this is what we can say. We can just shuffle it. We can just shuffle their position. So mu am will be equal to mu ma will be equal to mu 1 by mu am. Okay, so refractive index of air with respect to medium, if I do the reciprocal of it, we are getting refractive index of medium with respect to air. So now in this place, if we plot the value, if we put the value, we are getting qo by qy. Now qo by qy can be modified. How? Because qo and qi, okay, can be changed, because if we assume that q point is very near to p, okay, we have drawn it only to make you understand the concept better. The calculations becomes easier and easy to understand. That is why we have drawn it like this. But actually, P and Q points are very close to each other. That is why this distance QO, okay, when it comes very close to this point, QO becomes approximately equal to PO. So in place of QO, we can write PO. Similarly, in place of QI, we can write PI. So this is our new ratio. This is what we get. So from here we can say PO is our real depth and PI is our apparent depth. Real depth by apparent depth. So we get the relation. That means mu of any medium with respect to air should be equal to the real depth by apparent depth. Now apparent depth can be written as real depth. So we can find out apparent depth very easily. How? If we know the real depth and the refractive index of that medium inside which the object is put, inside which the object is kept. So this is what we get. Now if we want to find the shift, we can simply say that shift should be equal to real depth minus apparent depth. This is our shift, real depth minus apparent depth. So in place of apparent depth, we can write real depth by refractive index of the medium. If we take RD common, that means real depth common, it gives us shift equal to real depth within bracket 1 minus 1 by mu, the refractive index of the medium with respect to air. Okay, so this is our relation. This is our shift. I hope this thing is clear to you. Shift depends on some factors. It depends on refractive index of the medium. Okay, if the refractive index increases, it will have greater shift. Number two, the thickness of the denser medium. If the thickness of the denser medium increases, the shift will increase. If the wavelength of light increases, shift will decrease. These are the dependence. So, these are the factors on which the shift depends.